There would be a magnetic field there as well. However, a magnetic field diminishes much faster than the inverse square law because there are two poles acting on any magnetically susceptible masses that each vary with the inverse square law. If the poles are very close together, you don't have to go very far away to no longer feel any magnetic force at the poles. Hence, the magnetic field won't overpower the gravitational, dare we say, vortex. Well, it could be a vortex, since it would be twisting as well with the progress of the current or the heavier protons through or in the superfluid. The effect would be a repulsive force field from the output side and a tractor beam from the input side. Shades of Star Trek. Well, all we need now is a subspace radio channel. And I've got that too. My theoretical speed limit for gravity is 10 to the 39th power faster than light. That is, a gravitational signal should reach about to the Hubble radius in the time it takes light to cross the Compton wavelength of the proton. If we have an operational warp drive, we can slightly modulate its field and piggyback a signal on it. The question then would be, could the signal be picked up? And how far would it go till it was hopelessly attenuated? So where do these aliens come from? Well, they don't come from other planets, at least not now. They simply live in space. Space is their permanent home. Like landlubbers and seafarers, some people stay home while others get the itch to see the world, or in this case, the galaxy. Some of the species of aliens presently visiting us may be descendants of those who have left their home planets many millions of years ago. They probably live in vast flotillas of ships, whose sizes range from the things we get to see, all the way up to the big cans envisioned by Arthur C. Clarke in his science fiction novel, Rendezvous with Rama. In that novel, a big can did a flyby of the sun, and it was 50 miles long and 20 miles in diameter, as I recall. Internal gravity was by centrifugal force on the inside surface. It had its own weather. Anyway, I doubt that a big can could come into the solar system proper because of tidal forces and debris. It'd be cheaper to make a more vulnerable large craft with active defenses and basically keep it out of harm's way. The big cans would likely be parked in orbit just outside the solar system where it's most safe, and smaller vehicles would make the trip into the inner solar system. By smaller, I mean like only 1 or 2 miles long. They may also have semi-permanent bases under the ocean or on the dark side of the moon underground. These aliens are like people in the mall walking around looking at things. The mall is like the galaxy. The stores are points of interest, and the people are the flotillas. They are all different, but basically they all know and respect the same things, so they have few disagreements. One or a few of those alien species have probably adopted us and are our midwives during this period, which is basically a birthing process. They obey a fundamental premise which everybody knows. If it ain't broke, don't fix it. They are somewhat playful and anxious for us to hatch out and be real people. Imagine sitting on an egg for centuries. Maybe they get a little impatient, but they are ethically bound to wait and just watch. Every planet that develops an indigenous population undoubtedly is continuously sending out flotillas of explorers. Perhaps the average population of such a flotilla is a few hundred thousands of individuals. Who can say? Over the course of millions or even a billion years, there must be so many people living in space as to rival the number living on planets. And they don't have to go through space at greater than light speed. 1/1000th of light speed is the minimum, since individual solar systems have relative velocities on that scale. I suspect that they travel at something like 1/100th or 1/10th light speed and just amble around, encountering other flotillas coming and going, traveling down well-trodden space lanes which connect points of interest. We have been accustomed to think of our galaxy as a vast wasteland of empty space, whereas a much closer analogy might be that of bumper cars. Here is the setup for my earth-shattering experiment. I'm going the cheap route, as always. The rotating part is made from old DVD discs and lead fishing sinkers from Walmart. They look like little footballs with a hole down the axis. I smacked the sinkers onto concrete with a hammer a few times to flatten them so I could glue them onto the discs with a glue gun. Hot glue doesn't stick too well to DVD plastic, so I sandwiched the lead sinkers between two discs and slopped glue on the sides too. A messy business. I kept the sinkers from touching so as not to set up a big current flow. There will be eddy currents in each lead sinker, and the magnetic fields will, of course, oppose the magnetic field which generated them. But that's just normal physics. No violation there, just wasted energy. For the base of the experiment, I have used a DVD blank case. On the spindle, I constructed with cardboard and poster board a housing for my neodymium magnets, which I ordered online from CMS Magnetics. I ordered 20 magnets at about $1 a piece, but I could only get 10 of them in because they're too tough. They tend to pop out like popcorn, and it's just a mess. If I had to use all 20, I'd have to construct some kind of insertion device and a more robust housing, but I think 10 will do the trick. If I can't get a reaction with 10 magnets, I probably won't get a reaction from 20 or even 1,000. All of the magnets are oriented with the same pole up, so they are all repelling one another outward from the axis of the machine. Now, if there is an effect when the lead sinkers are rotated over the stationary magnets' up lines, that effect would be opposite when going through the down lines.